All right, so this is another graphing of linear inequalities. Again, before we start graphing, please be aware that if it's less than or greater than, you would have a dashed line. If it's greater than or equal to or less than or equal to, then you have a solid line. All right, so we have two inequality to graph. Okay, you have the blue and the purple. Tell me, how would you want to graph the blue? Which method do you want to graph? Plotting point, x and y intercept, or slope-intercept form? Slope-intercept form, because it's so pretty, huh? So here, the first thing we need is find the boundary. To find the boundary, you have to set inequality to be equal. We only do this to find our boundary. Am I already in a slope-intercept form?
Yes.
Yes, I am. Tell me what's my slope is. Negative 2 over 1, very good. Tell me what's my y-intercept is.
0.
Thank you. Okay, so let's go in and graph our blue inequality. The first thing we found is boundary. So here it says the y-intercept is 0, 0. I'm standing on it. Tell me how to get the next point.
Down.
Using the slope to find the next point. Down 2. 1, 2 over 1. Here it is. Before I connect them, always go back to what the original condition was. The condition was less than. So what kind of line do we have? Dash. Here's my dash. All right. So 1, I found the boundary. 2, what do we need? We need to see what region do we belong to, either this side or that side. This is when you pick any point your heart desire, as long as you're not on my line. So, pick a point.
1, 1.
1, 1? 1, 1's right here. Can I pick 1, 0? 5, 0?
Yes.
You could pick anything your heart desire, but here, Mindy, 1, 1, 1. All right, here's your 1, 1. 1, 1. All right, you're going to take that point and you're going to plug into the original. Y is 1 less than negative 2 times 1, so it's 1 less than negative 2. Is 1 less than negative 2?
No.
Yes or no? No, so this is false. So if this is false, then what side do you belong to? That's right, you do not belong here. You belong here. So shade the side. Good. Now let's graph our purple one. So purple one, I'm going to go up. Okay, this is going to be our purple one. The first thing we need is our boundary. To get the boundary, I have to set this to equal just to get my boundary, which is your line. Here it is. How would you like to graph this? Slope-intercept form. Right? What's my slope?
Negative 5 over 1.
Negative 5 over 1. What is my y-intercept?
0, 0.
0, 0. All right. So I'm going to go in and graph my purple boundary or purple line at the moment. So my y-intercept is 0, 0. Here I am. Tell me how to move.
Down 5.
1, 2, 3, 4, 5.
Right 1.
Right 1. So I'm going to say about right here. Before I connect them, always go back to your original condition. What kind of boundary do you have? Or what kind of line do you have? Solid, because it's greater than or equal to. When it's greater than or equal to, it's a solid line. Here is my solid line. Pretend that's a straight line. Okay? Now, once again, you have a purple line or purple boundary. What side do you belong to? To this side or this side? That's step 2. Pick any point your heart desire, as long as not on that line. What do you want?
0, negative.
0, negative. It's too close. You see it?
1, 1.
Let's pick 1, 1 again because it's way off the radar. You see it? Because it's not close enough to the purple line that I don't have to guess. So let's pick 1, 1 again. Here. So I'm picking 1, 1. So 1 greater than or equal to negative 5 times 1. So 1 greater than or equal to negative 5 times 1, which is negative 5. Is 1 greater or equal to negative 5?
Yes.
Is that true? That's true. If that's true, then the side that you pick is a good side, right? So shade them. I hope you see the overlap. Tell me which region that the blue and the purple graph overlap. They don't overlap here, not here, not here, not here. Look where they overlap. Right? This itsy bitsy region here. You see it? That means every single point that is squeezed between the two, every single point here will satisfy both of this condition. That's what it meant to be a solution. If I pick a point here, what that point satisfy? It only satisfied the purple. You see it? If I pick a point here, it doesn't satisfy any. If I pick a point here, it only satisfies the blue. Not good enough. We need to satisfy both. So therefore, every single point here will satisfy both. And this is your solution. How is it? Easy? Yeah?